Okay, so before we do the front of your note page today, let's flip it over on the back really quickly and take 3 minutes or so to fill out this table of values for your exponents. So here are your base numbers 2 through 10, and you're raising them to these powers. So take 3 minutes, press pause on the video. When everybody's done in 3 minutes, we'll come back and take notes on the other side. Okay, so let's go back to the other side and let's fill out the top of your note page. So today's objective, 6.1a, is all about exponential equations, but just the basics. It's not going to require logarithms for us to solve any of these equations. Okay, we can just use our exponent rules and we can zoom right through this. And this is just prepping us to do some graphing of logarithms and exponentials. So here we go. Your objective, you will be successful when you can use the exponent rules and common bases, not logs, common bases to solve for the missing exponent. So let's start with the product rule for exponents. Let's remember some of our rules. Product rule basically says if I have some number b, some base number b, and I raise it to the m power, and I multiply it by that same base raised to the nth power, then I can simply add the exponents. And if you wanted a little reminder, it's just like if I go x times x squared, you guys have no problem telling me that's x to the third because you're adding the first power, power of 1 plus the power of 2. So that's that idea there. Quotient rule for exponents, pretty similar. Says if I have some base number raised to the m power over some same base number raised to the nth power, then I can subtract those exponents, subtract the denominator from the numerator. So there's a quotient rule. Power rule for exponents says that if I have some base raised to the m power, and I raise that to the nth power, that I would use a distributive property here and I would multiply the powers together. All right, negative exponent rule says that if I have some base number raised to the negative nth power, that's the same as 1 over that base raised to the positive nth power. And remember that these things go both ways. So if your base is in the denominator, you're going to raise it to the numerator if you want to write same bases. You'll see that happen when we get some fractions and some of the problems that we're working on. All right, zero exponent rule says if I raise any base to the 0 power, I get 1 as long as your base is not 0. Actually, double check me on that. Let me check my calculator. Maybe 0 to the 0 power is 1. Let me look. No, I am correct. That does give you a domain error. So 0 to the 0 power is not 1. It's not possible. All right. And then last one is the same base rule. And this is a rule that applies to equations. So it says this: if we have some base raised to the mth power, and it's equal to the same base raised to the nth power, then we can say that the powers are equivalent as long as b is not 1. And so we will be using this rule often. You can see it actually in this example here where we have two bases that are the same, and if their bases are the same, then their exponents are equivalent. That's basically what that rule says. So here are the steps that we're going to follow. Step 1 is you are going to identify a common base on common bases, on the left and right. And then, of course, you're going to have to apply any exponent rules that'll help simplify the left and the right. Simplify left and right, sorry, so that you have a single base on each side. To simplify until single base on each side. And then what you're going to do is you're going to apply the same base rule. If the bases are the same, you'll set the exponents equal to each other. So exponent equals exponent, and then solve for x. And then I would suggest that you want to make sure that you're correct. You can actually go ahead and plug your x into the calculator and see if you get equivalent values on each side of the equation. I'll show you. All right, so let's start with first example here. Excuse me. I'm going to pause for a sec. Oh, this asthma is killing me. Okay, so here we're looking at this problem where we have 6 raised to the x plus 2 equals 6 raised to the negative 3x minus 4. So we're already at this step 2 where we have the same base on the left and the right, and there's a single base on the left and the right. So we can go ahead and just set the exponents equal to each other, because if the bases are equal, then the exponents are equivalent. Then we just solve for x. So I'll add 3x over here and subtract the 2 over there, and we get 4x. Check my math, equals negative 6. Divide by 4. That's not a negative 4. And so we get negative 3/2. And then quickly we can plug that into our calculator, or plug it into the equation. We can just plug in negative 3/2. So negative 3/2 plus 2, and then 6 to the negative 3 times negative 3/2 minus 4. And I'll plug that into my calculator. So this is 6 to the half power equals what? That's 6 to the negative 9/2 minus 8/2, positive 9/2 minus 8/2. So that's basically 6 to the half equals 6 to the half. And that's just plugging it in. Of course, you plug it into your calculator. And let me do that real quick. So 6 to the negative 3 over 2 plus 2 Hang on, I'm going to pause because my calculator did something silly. Okay, so basically I plugged this into my calculator, and then I plugged this into my calculator, and what I got was 2.449 and some more numbers equals 2.449. And so you can see that it's true. So you can plug it in and do it by hand, or you can just plug it, the statement with the values substituted into your calculator and get the approximated decimal version of the answer, and you can see that you're correct or you're incorrect. So just make sure you're checking your answers. All right, let's take a look at this next one here. We have 4 to the x squared equals 4 to the 2x plus 3. So step 1 is identify common bases on the left and right. That's already the situation. So we'll apply the exponent rules to simplify. Well, we don't need to simplify. Single base on each side. So if the bases are the same, then the exponents are equivalent. So we get x squared equals 2x plus 3. All right, so that's definitely going to require us to use our zeros in the quadratic. So we'll take these quantities to the left. So x squared minus 2x minus 3 equals 0. And then we'll open up our binomial pairs and factor to x minus 3x plus 1. Double check me. Multiplies to negative 3, adds to negative 2. Perfect. So get in your zeros. We know x is equal to 3 or x is equal to negative 1. Again, you can check those quickly in your calculator by doing, okay, so we're going to plug in the 3 first. So 4 to the 3 squared, which is the same as 4 to the 9th, is equal to 4 to the 2 times 3 plus 3. And when you plug that in and do that math, you can see that that's 4 to the 9th. So that's a quick one to check. And also plug in the negative 1. So I'll do that over here. So 4 to the negative 1 squared is equal to 4 to the 2 times negative 1 plus 3. And then you got 4 to the first power is equal to, that's a negative 2 plus 3, 4 to the first power. So you can see that that's true as well. So good solution. All right. Now we'll move on to ones that are going to require us to take more steps. So let's take a look at this next example. Here we have a base 4 and a base half. And neither of those, I can't make 4 into a half. I can't make half into a base 4. So I'm going to have to make them into their common base. So I'm going to go with a base 2 because 4 I can write as base 2 squared. 4 is 2 squared to the negative x. So I'm just using substitution, replacing 4 with a 2 squared. Put parentheses around it. Be really careful. And I'll put parentheses around that exponent. Then over here, half is 2 to the negative 1. If you recall, if I look at it like this, you can see that. That's 2 to the negative 1. All right. And so we're using substitution. I'm going to erase a little bit so I have some room here. All right. And we're going to raise that to the x plus 2. And so here's what we have. We have same base, but on step 2, we need to apply our exponent rules and simplify. So here we have 2, and we're going to apply the power rule here. So that would be to the negative 16x equals 2, and you need to distribute here to the negative x minus 2. There you go. Same basis, simplified using the exponent rule. So if the bases are the same, then the exponents are equivalent. Negative x minus 2. We'll add x to the other side. We get negative 15x equals negative 2. Divide by negative 15. X equals 2/15. And then my suggestion is you still continue to check your answers to make sure that they are correct. If you need to take a moment to ask Mr. Harris to pause so that you can talk about that with each other, just let him know. Otherwise, we're moving on. Okay. Next example, here we have two bases, 25 and 5. They're not the same base, but it's really easy to write 25 as a base 5, so we'll just substitute in a 5 squared so that we have same base. 5 squared to the x squared is equal to 5 to the 5 minus 4x. All right, so we're going to apply our power rule here so that we can simplify this. So we have 5 to the 2x squared equals 5 to the 5 minus 4x. So same bases. If the bases are equal, then the exponents are equivalent. 5 minus 4x. And then we're going to solve for x. You can see the quadratic appear here as well. So we will have to find the zeros. So we'll move these two terms to the other side. So 2x squared plus 4x minus 5 equals 0. All right, let's make sure this is factorable. We may have to break out our quadratic formula here. It looks like we will. And so what was I thinking? Let's go ahead and get our quadratic formula out. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, and let's simplify that. I think that will be okay. This will be positive in here. So let's do a little more math. So that's 4 plus or minus the square root. Let me get my calculator real quick. 16. My battery just died. Great. 16 plus, what's that? 8 times 5 plus 40. So that's the square root of 56 all over 4. And then 56, I believe we can break down. There's a large square root in 56, so let me grab that up real quick. That's 2 square root of 14, so we'll break that down. So x is equal to negative 4 plus or minus 2 square root of 14 over 4. And then don't forget to simplify, so you got to give it a little love there. X is equal to, the greatest common factor of those values is 2. So we're going to go negative 2 plus or minus the square root of 14 over 2. So you have your positive version and your negative version. Here's what I promise you. On your homework, you won't have to use the quadratic formula to solve for your x's. Okay? So, but you never know. Sometimes they pop up and you can't factor your quadratic, so you got to use the quadratic formula. Oops. All right, last problem. Let's hope I didn't make another mistake here. Okay, so this problem's quite a bit more daunting when you look at it, because you've got 4 different bases here, and the rule, and basically what we want to do is we want to get a single base on each side. So let's identify the common base on the left and right. We're looking at 64, half, 8, and 2, and I believe we can write those all as base 2. 64 is the same as 2 to the 6th power to the x power. So we're just replacing 64 with 2 to the 6th. 1/2 is the same as saying 2 to the -1 power, and we'll raise that to the x minus 2 power. Put a parentheses around that quantity. 8 is 2 cubed. We'll substitute that in. And then this is already a base 2, but let's go ahead and use our power rule here to the 3x. All right, so we have identified common bases on the left and the right. Now we'll apply our exponent rules and we'll simplify until the single base on each side. So let's apply our power rule here. So 2 to the 6x times 2, and we'll distribute that -1 there, to the -x plus 2. And over here we have 2 to the 3 times 2 to the 3x. Okay, so we have simplified, but we need a single base on each side. So what we're going to do now is we're going to apply the product rule. The product rule up here, if you remember, right here, the product rule. If we have 2 bases that are the same and we're multiplying them, we can add the exponents. So bringing it back down here, we have same base. So we're just going to add 6x plus the quantity -x plus 2, single base on the left. Same rule over here. We're going to do 2 to the 3 plus 3x. So we multiply those same bases by adding their exponents. All right, so now we can apply step 3 that says if the bases are the same, then the exponents are equivalent. So 6x plus -x plus 2 equals 3x. 3 plus 3x. And then we'll simplify, so we get 5x plus 2, 3 plus 3x. We'll subtract the 3x to the left and subtract the 2 to the right. So we get 2x equals 1 and x equals 1/2. Again, please check with your calculators to make sure that your answers are correct. Okay, guys, so your homework or your assignment is to do problems 1 through 10 on the worksheet you picked up on the way in, and we'll go ahead and label it 6.1a. Have a good one. Be good. See you on Monday.